In this tutorial, we will be discussing the scientific method. Chemists use the scientific method, a way of learning that emphasizes observation and experimentation, to produce knowledge as a result of the senses. The scientific method stands in contrast to ancient Greek philosophies and medieval applications of them that emphasize reason to produce knowledge as a result of thoughts. We're going to start off with observations. Observations involve measuring or observing some aspect of nature. And that leads us to hypotheses. Hypotheses are tentative interpretations of the observations. Laws summarize the results of large number of observations. Then over here, theories are models that explain, note the word explain, and give the underlying causes for the observations and laws. Hypotheses, laws, and theories must be tested and validated by experiment. If they are not confirmed, they are revised and tested through further experimentation. Some observations can be made with the naked eye. Other observations emerge from experiments that rely on the use of sensitive instrumentation. Observation usually involves the measurement or description of some aspect of the physical world. For example, Antoine Lavoisier, a French chemist, made an observation about the physical world. He measured the property of mass, which is the mass of an object is the measure of the quantity of matter within it. So he measured the property of mass, of how much matter there was in a process of combustion, which means burning. He measured the mass in each container and its contents both before and after burning the substance inside, noting that there was no change in the mass during the combustion process. Observations lead scientists to formulate a hypothesis, a tentative interpretation or explanation of the observations. A good hypothesis is falsifiable, which means that further testing has a potential to prove it wrong. Hypotheses are tested by experiments, which are highly controlled observations designed to validate or invalidate hypotheses. The results of an experiment may confirm a hypothesis or show it to be mistaken in some way. The hypothesis may have to be modified or discarded altogether and replaced by an alternative. The new or revised hypothesis must also be tested through further experimentation. A number of similar observations lead to the development of the scientific law. This is a brief statement that synthesizes past observations and predicts future ones. Lavoisier developed the law of conservation of mass through his experiments of testing the mass of the combustion reactions before and after. And it states that in a chemical reaction, matter is neither created nor destroyed. One or more well-tested hypotheses may form a basis for a scientific theory. Theories provide a broader and deeper explanation for observations and laws. They are models of the way nature is. They often predict behavior that extends well beyond the observations and laws on which they are founded. Remember, we're looking for explanations when we're looking for scientific theories. Established theories with strong experimental support are the most powerful pieces of scientific knowledge. People unfamiliar with science sometimes say that's just a theory, as if theories were mere speculations. However, well-tested theories are as close to truth as we can get in science. If a law, hypothesis, or theory is inconsistent with the findings of an experiment, it must be revised and new experiments must be conducted to test the revisions. Over time, poor theories are eliminated and good theories, those consistent with the experiments, remain. Here's an example. John Dalton with the atomic theory. Dalton explained the law of conservation of mass, which is what Lavoisier did, by proposing that all matter was composed of small, indestructible particles called atoms. Dalton's theory was a model of the physical world. So he's explaining why the mass was not changing, and went beyond the law and the observations of the time to explain these laws and observations. The key word to theories are explanations. The idea that all matter is made of atoms is a theory with 200 years of experimental evidence to support it. So Dalton made a theory to explain Lavoisier's law. Lavoisier just simply stated, this is what happened. This was my observation. And he tested it time and time again, and he created a law. Whereas Dalton gave a reason for what Lavoisier was observing. And here is further proof of the atom. Modern technology provides recent images, such as this one, of atoms themselves. Each one of these little dots are atoms. This image shows the characters of the kanji characters for the word atom, written in individual iron atoms on top of a copper surface. So the purple is a close-up of iron atoms, spelling out the word atom. And that gives you information on the scientific method.